Hi, my name is Walker Krabakian, and in my project, Capacitors, Capacitors, Rises, I was trying to figure out if you could judge a capacitor's capacity by the capacitor's size. Basically, what a capacitor is a device that holds a charge in the form of an electric field. It's basically two plates separated by a dielectric. What I needed in my project were 10 electric capacitors chosen at random, and each of them must have been rated at or above 12 volts. Their voltage rating. A breadboard, a 4.6K ohm resistor, a switch, many wires, alligator clips, and needle nose pliers, ammeter for current, voltmeter for voltage, ohmmeter for resistance, timer, video camera, batteries, or a DC power supply, a Dremel cutter, protective eye goggles, or an air mask. And an air mask. So in my project, I had to do preparation and an experiment because I had to set a couple of things up. Of course, I had to gather the materials. I had to select the 10 random electrolytic capacitors, and I had to cover each capacitor with a piece of paper, so I couldn't see their voltage rating or their resistance rating. I mean their capacity rating. I had to label my capacitors A through J. I had to arrange the capacitors in order which I thought was least to greatest capacity. I had to record that order. And I had to use these calipers, which are basically measuring tools. They're very precise, so I would prefer for you to use one in measuring. And I had to calculate the volume of each capacitor. And I had to set up a capacitor charging circuit on a breadboard, which is basically a tool to help you make circuits. I had to set up the video camera, and the timer, the ammeter, voltmeter, switch, and the labeled capacitor. And I had to set up the power supply to provide 12 volts DC. Now, I highly recommend before you set up the DC power supply, you open the switch. Because if you don't, then you might be in a little bit of trouble. And we need to place the capacitor in the circuit and discharge the capacitor by placing a wire across the metal leads of the capacitor. This will make the voltmeter read 0 and the ammeter read 0. Then you have to 0 at the timer and start the video camera. Close the switch and turn on the timer to begin the charging circuit. Then after, when the voltage reaches near 12 volts or the current reaches 0.001, it stays there for 5 seconds, then you're done with the circuit and you turn off. Okay, then after that, you need to record, you need to replay the video and record the values of current and voltage for each second for the first 15 seconds, then for each 5 seconds for the next 30 seconds. Then you just do 30-second intervals until the charging stops. Okay, then I would do this 2 times for each capacitor, and I would record each time. Then, after the second experiment, of course, I would get rid of the paper on the capacitors and record the rated values of voltage and capacitance. You can see that by looking at the summary data table. In my summary chart, it shows my guess of which you can see over here too. And the volume of it, the maximum time, the area of plates, and the capacity rating. But you first should know how I found why I needed the area of plates. It's because of a formula to find capacitance, to see why I got these results. It's capacitance equals dielectric permittivity in area of plates over the distance between the plates, and that's the capacity. So I went inside and I found the area of the plates by using a ruler. And my conclusions for my experiment. The results, even though some electric little capacitors at a larger size, they were not guaranteed to have a larger capacity. So this proves my hypothesis wrong. Even if the plates inside a capacitor had a larger area, they were not guaranteed to have a larger capacity than the one with a smaller plate area. Of course, you noted this was definitely a surprise because of the formula I showed you. The reason of this surprise is probably because of the different materials they use to make the capacitors for the dielectric for the plates. So that's my experiment, and hope you liked it. Bye.